The era of just making models bigger is ending. Today, the winners are the ones who can make them cheaper, safer, and more useful. And that shift is creating some strange new pressures. From Microsoft's new cost metric to NVIDIA's safety guardrails to a bizarre study on symmetry and data, today's stories all point to the same thing. AI's real test is no longer intelligence, it's practicality. This is exactly why the hype to deployment gap matters. Meta has delayed the public API for its Muse Spark model again, and they haven't set a new date. They say testing with early partners is ongoing, but the lack of a timeline leaves developers waiting. It's a reminder that building a competitive model is one thing, shipping it reliably is another. The same pressure shows up in the enterprise. Microsoft is rolling out a new metric on its model cards, average token usage, or what they call intelligence per dollar. This forces AI providers to compete not just on capability, but on efficiency. Enterprise buyers who care about cost per outcome finally have a clear benchmark, which raises the stakes for specialized models. OpenAI upgraded GPT Rosalind with the deeper expertise in medicinal chemistry and genomics. It now outperforms prior versions on a new life sciences benchmark. But it's only available in research preview via trusted access. This is a sign that domain-specific safety and validation are becoming the new competitive moats. But that sets up something bigger. If you want to deploy globally, you need scalable safety. NVIDIA's Nemotron 3.5 content safety model adds multimodal evaluation in 12 languages, plus custom policy enforcement. It even includes optional reasoning traces for auditable decisions. For enterprises dealing with regulatory compliance, this is a direct answer. And that's where it gets strange. At CVPR, NVIDIA Research unveiled 3 foundation models built on billions of simulated samples. One lets any robot gripper plan grasps without a training. Another speeds autonomous driving reasoning on embedded hardware. A third scales embodied agent training across massive virtual worlds. These aren't just demos. They're aimed at real physical deployment. Finally, this study shows the mathematical foundation of the entire shift. Researchers experimentally measured how architectural symmetry reduces data needs. On a controlled task, equivariant networks needed about 28% less data than generic ones. The wrong symmetry hurts performance, but the right inductive bias pays off. This is exactly the kind of efficiency gain that makes AI practical in the real world. So, where does this leave us? AI is entering a phase where the hardest problems aren't algorithmic, they're operational. Efficiency, safety, specialization, and real-world validation are the new battlegrounds. Watch for who can deliver not just the smartest model, but the most deployable one.